Hello students. In previous video we did derive expression for intensity in terms of distance x and capital D. Now in this video we'll derive the expression for position of bright fringe and dark fringe from center in case of interference due to two coherent waves. And we'll also see what is stationary wave and what are the conditions for stationary interference to take place. As we derived in earlier video, I can be given as 4I0 cos square k R2 minus R1 by 2. This is one equation of intensity. And then last time we had new relation between R1 minus R2, which is given as this. And using this relation, intensity can be given as I is equal to 4I0 cos square k x d, sorry, small d by 2d. What is x? X is the distance of given point from center of the screen. So if I have say S1 and S2 separated by distance d, and if screen is placed at capital D distance, and if I consider the centers of S1 S2 to be say S, let this center be O, and let there be some point P which is at distance x. Then what will happen at point P, which is at x distance, whether I'll have dark fringe or bright fringe occurring there? So that is what we are trying to find out here. Earlier we had condition for constructive and destructive interference, but that was in terms of R1 minus R2, in terms of path difference. Now we'll find it out in terms of x. So again, for constructive interference, the cost term has to be 1. So constructive interference means bright fringe if you are talking about, then intensity I has to be equal to 4I0, and for that cost term cos kxd by 2d has to be plus or minus 1. It means that kxd by 2d must be equal to 0 or pi or 2 pi or n pi. So kxd by 2d is equal to n pi, where n starts from 0, 1, 2, 3. Now this is one way of deriving it. The other way is directly you can use this equation and put n lambda here. With both you will end up with same result. So here if I make x subject of formula, what I have, x is equal to 2n pi d by kd, and k is 2 pi by lambda. So substituting that we get x to be n, let me substitute it, 2n pi d by d 2 pi by lambda. Okay, so this 2 pi and this will be cancelled out. So what you will be left with? You will be left with d by d into n lambda. If this condition is satisfied at x, constructive interference will take place. So this is the condition for constructive interference. Say here if we take n lambda, we will end up with same result. Okay, similarly for destructive interference, at which position, at which distance destructive interference will take place. So again for destructive interference, I should be equal to 0. It means that cos kxd by 2d must be equal to 0, which is possible only if kxd by 2d becomes pi by 2 or 3 pi by 2 or pi by 5 pi by 2, so on. So in short, I can say that kxd by 2d, if it becomes equal to odd multiple of pi by 2, then at those values of x, destructive interference will take place, dark fringe will occur. Again, be careful. In constructive interference, n starts from 0. In destructive, it starts from 1. So again, in this equation, if I make x subject of formula, no, let me change the way. I take k to be 2 pi by lambda here itself. And now if I simplify it for x, what do I get? I get x to be equal to, here this 2 and 2 will get cancelled out, pi and pi will get cancelled out. So what I'm left with is d by d 2n minus 1 lambda by 2. So this is the condition for x point to be dark. N is 1, 2, 3 here, n is 0, 1, 2. So these are the values of x at which for these values of x the point will be bright, for these values of x point will be dark. Thank you.